So project title, battery current sharing power decoupling method for the realizing a single state hybrid PV system. So in this project, we are using one method, advanced method, that is a battery current sharing power decoupling method. So this method is used to improve the power efficiency in the PV systems with the help of battery placement, right? So previously we are using normal construction to improve the system. So MPPT technique is the method to improve the power efficiency in a PV system, right? In our system, we are using the BCSPD, that means battery current sharing power decoupling method. So in our project, we are using the PV system to operating at a maximum power, right? But so for the short lifetime electrical capacitors will reduce the PV inverter reliability. So that to overcome this problem, we are using a concept that is a battery current sharing power decoupling method to improve the system performance, right? These system performance will be implemented in different configurations. So this is our system configuration, right? Single stage PV inverter, right? So this is the two-stage PV power system, and also this is the hybrid PV power system. This concept will be implemented in our project like this is the our proposed system. This is the single stage only. So we are using the same concept, but we are using the our proposed, right, battery current power sharing decoupling method, right? This method will be implemented with a different conditions. That means our whole system will be implemented how much of voltage and how much of current, right, and how much of inverter current and how much of change of voltage will be presented. So like this. So this is existing circuit waveforms. So experimental waveforms, so this is the experimental, but this concept will be implemented in MATLAB like this, right? So here we are using the concept, but the switch we are using here, this is the open circuit because we are not connecting the battery in our system. That means this is the old circuit. So for this circuit, so what is the output voltage waveforms, right? So this is the waveforms we are measuring like this, right? So across the voltage. So this is the way we can measure the conditions, right? So totally we can present like this: voltages, PV voltages, PV current, right? Inverter current. So like this, okay? So next condition, whenever the switch is closed, our proposed BCA PSD conditions will be implemented. So that is figure 19F. So here we are using the circuit close. So this is our proposed circuit we are implementing in our concept. So next figure 19 like this, right? These waveforms will be represent like this. So this is the voltage magnitude levels we can observe in the base paper also. So next, whenever the conditions, the temperatures will be night time or morning time. So the temperatures will be different. The output voltages also different. So here we are using the daytime and night time. That means the daytime we are using the temperature levels maximum 35 degrees centigrade. So in the night time I am using the 10 degrees centigrade only. So for this condition, we have the different cases like this. So here we are using the PV system. So 35 degrees centigrade, right? So for this condition, so we're presenting like this, right? So for the nighttime conditions, the temperature will be low. So for example, I'm taking the 15 degrees centigrade, right? So for this condition, so the PV voltage will be variations, right? So like this, our project will be successfully completed.